In this video, we're going to talk about drawing Lewis structures for simple molecular compounds. And just as a quick note, molecular compounds and covalent molecules are the same thing. So those two terms are interchangeable, and I do have a tendency to bounce back and forth between them, as does the book. So do understand that both of those mean the same thing. And then the second thing we'll look at here is looking at Lewis structures and trying to identify bonding and non-bonding electrons. So with ionic compounds, we started by looking at the Lewis symbol for elements, individual atoms, and then we moved on to show how the electrons are transferred. For Lewis structures for covalent molecules, we're going to show how the electrons are shared, because that's what's happening. So two electrons between the two atoms, as we have here with hydrogen, those are bonding electrons. Those are the electrons forming the chemical bond and holding the atoms together. If we look at HF, again, we have two bonding electrons, but we also then have 6 total non-bonding electrons. So those 6 that I've highlighted in green are only counted by the fluorine atom. So they're not involved with the hydrogen, so hydrogen does not count them. Hydrogen will only count the 2 in the bond, and that's all it needs. Fluorine can count those 2 plus the 6 non-bonding electrons for a total of 8 for its full octet. Here in F2, we have the 2 bonding electrons shared between the 2 atoms again, and then both fluorines have a total of 6 non-bonding electrons. Bromine-fluorine bond, we've got the 2 that are shared and the bonding electrons, and again a total of 6 each for the non-bonding electrons on each atom. Whenever you have the 2 electrons paired, and we're talking about non-bonding, this is also called a lone pair. So while you can say this fluorine has 6 non-bonding electrons, you could also say that it has 3 lone pairs. It's just another way of counting. So if you're asked a question about non-bonding electrons versus lone pairs, make sure you're counting correctly. So this problem says how many lone pairs and bonding pairs are in the Lewis structure. So again, we're talking about pairs. So lone pairs is 2 electrons, and bonding pairs is going to be the 2 that are within a bond. And we didn't see this yet. Whenever you have a single line, that's a chemical bond, and that's representing 2 electrons. So every line is 2 electrons. Drawing lines is just simpler than having to draw all these dots, so it's kind of the shorthand way of doing it. And it's also a little bit easier to see once you understand that it's 2 electrons. So how many lone pairs are in this structure? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 pairs, so 12 lone pairs, which is a total of 24 non-bonding electrons. And then for bonding pairs, we have 1, 2, 3, 4 bonding pairs. For a total of 8 bonding electrons.